Good morning, I'm Hanh, and today I will be presenting on Assignment 2, Project Execution, AWS Cloud. So the scenario of this assignment is building two websites, a static one to showcase the visiting information, and a dynamic one that manages our product data through a secure private backend database. Moving to task A, I need to create the VPC. So in the search bar, search VPC. And navigate to VPC dashboard and create VPC. Leave the VPC only here. The name tag, I will name it after my student number. In IPv4, it will be 10.0.0.0/16 to give plenty of IP space for subnets later. And I leave IPv6 and Tennessee as default. Then click create. Now I'm creating subnets for two different availability zones. So moving to subnets and create subnets. I select my VPC. The second one is public subnet 1. Availability zone, I would choose US East 1A. And for the public subnets in availability zone A, I would use 10.0.1.0/24 in a new subnet. This one would be private subnet 1. Availability zone is same as the public. And for private, I use 10.0.2.0/24. Then I repeat for the second availability zone, public subnet 2. This one I would use US East 1B. And I would assign it to 10.0.3.0/24. And the private subnet 2 is 10.0.4.0/24. Okay, I assign them to US East 1B. So this ensures both tolerance and distribution across multiple zones. Then create subnets. Next step, we will create root table. So one for public subnets will have internet access, and one for private subnets, which no direct internet access. Root table. And I select my VPC. After you have root table, so you need to associate subnets with root table. Associate. I would associate this one is public. And do the same with private ones. So let me change the name a little bit. This one is public. Next, I create the root table for private. Select my VPC, then create root. Okay, let's associate it. This one, I will select private and subnet 1 and private subnet 2. Okay, so next step is we have to enable internet access for public subnets only. Next step, we need to enable internet access for public subnet only. So moving to internet gateway, create internet gateway. The name tag here is S402 my SID internet gateway. Then create internet gateway. So to allow the internet access for the public subnet, I create internet gateway and attach it to the VPC. Okay. So then I update the public root table to include the root of internet gateway. So to update that, I need to include the root. I will select this one, select internet gateway, and my internet gateway. So this means all outbound traffic from the public subnet can reach the internet. Save change. Okay, so let's have the final check. Move to your VPC, select my VPC here. Okay, let's move to resource map. Okay, so in here we got VPC created for subnet across two availability zones. In the public root table, we include two subnet association and two root, including local. And the same at private, we have two subnet association and one root, including local. And in public subnet, we also connect to the internet gateway. The internet root has two public subnets. At this point, my custom VPC is ready, and I manually create two availability zones with each public and private subnet, assign them to root table, and configure internet access for public subnets only. Here's the list of reference I used in task A, create VPC. In task A, I use the lab, view your VPC and launch a web server, and I use sandbox for practicing. Also, I watch videos about Amazon VPC in AWS Academy. And the last one, I read lectures like in RMIT Canvas. Moving to task B, so we are hosting a study website on EC2. So first, we go to EC2 dashboard, choose security group, and create security group. I would name it as Web SG, and as description, I choose the VPC here. And in inbound rules, add rule type SSH with the port rank is 22. And the CIDR here, I choose the first one and add new rule for HTTP with the port range is 18. And the CIDR here, I choose this one. And I create a security group. And now we are creating an EC2 instance. So go to the instance, click launch instance. And I would name it as my SID. I choose application. Here is Amazon Linux with a free tier. The instance type here is the T2 micro. And in the key pair, I'll choose bold key. In network setting, click edit and choose my VPC. And here I would choose the public one. In the firewall, I select the existing security group and select the web. And now I launch Instant. Next step is we are going to create and allocate elastic IP address. I click Allocate. And now we should associate this elastic IP address. In the result type, I choose Instant. And in the Instant, I choose my web. And I associate it. So now let's connect to my EC2 Instant. So move to Instant. Select the EC2 instance and click Connect. And it should appear the console here. So first one, we need to switch to the root user. So it would be sudo su. And now we should update installed bucket, which is yum update http dy. So next we should install the Apache. So then we'll go to the web directory and download the study website zip files. So it will be winget and the file. And now we unzip the files. And now we're starting the service. So let's check the website. Now we copy the public IPv4 here and paste to the new tab. Welcome to the cafe. So this is how I hosting a website with EC2. Here are some resources in task B, build study website with EC2. So in task B, I used the lab introduced to Amazon EC2 in Model 6 Compute and in AWS Academy. And I also watched some videos about console demonstration EC2 and some Amazon EC2 videos in Model 6, also in AWS Academy. And again, I use sandbox environment for practicing. Proceeding to task C, hosting a study website on AWS S3. So we navigate to S3 service. Now click Create Bucket and name the bucket. And now I leave all other settings defaults for now and click Create. So now we go into the newly created bucket, click Upload, and now I prefer to add folder. Make sure to upload all files and folder related to your website. And now click Upload. The next step is I want to enable static website hosting. So in the bucket, click Property, scroll down to static website hosting, choose Edit, and select Enable static website hosting. keep the whole static website type. In the index document, I type my index.html and I leave the arrow document empty. Now click Save Change. And now I want to make the packet public, so go to the Permission tab, find the block Public Access, choose Edit, and uncheck Block All Public Access, and I will save change. Make sure that you confirm it. So now we should update object permission. So still with the permissions, go down to Object Ownership, choose Edit, and choose Enable ACLs. Click Acknowledge, and confirm and save change. After we successfully edited object ownership, we want to make the object public. So go back to Object, select all the photos, click on Action, and choose Make Public using ACL, and confirm it. So now we can access the website. So in the Object tab, click on the folder, choose the index.html. Now copy the object URL here. Go to the New tab and paste the link. And now you will see the cafe website appear. So this is how I host a static website with AWS S3. This is the reference of Task C, build static website with S3. In Task C, I watched some videos about AWS S3 and console demonstration in Model 7 storage in AWS Academy. Also, I use sandbox environments for practicing with S3. Now we turn our focus to Task D, how to host a static website on AWS with Elastic Beanstalk. So first, click on Elastic Beanstalk and click Create Application. So first, I will enter my application name. And under the platform, pick any available option. So even though it's a study website, but you can choose any platform. So in this example, I will select Tomcat and leave other setting default. In the application code, I would upload my code, choose the local file, and choose file. I will choose the zip one. And I would name the version label. So this is the ver1. And now we select the single instance for freeze tier. So let's next into the next step. In the configure service, I will select the use existing service rule. And now I choose the lab rule here. In easy to keep pair, I select the vault key. And finally, in the easy to instant profile, I'll choose the lab instant profile and move to the next step. So in step 3, step 4, and step 5, I will leave everything else as the default. And then I go to skip to the review. And now I submit it. So now we wait a few minutes while AWS sets everything up. So once the environment is ready, so we are looking to the domain here and click URL and done. So now the starter website is now live and accessible to the public. In test D reference, I watch videos about introductions to AWS Elastic Beanstalk in Module 6, AWS Academy. Also, I did lab activities, AWS Elastic Beanstalk in Module 6, AWS Academy also. And again, I use sandbox environment for practicing study website with Elastic Beanstalk. We now proceed to task E for deploying the EC2 instance in a second availability zone using a load balancer, auto-scaling group, and scaling policy. So first of all, we need to create an AMI for auto-scaling. So first of all, we need to navigate to EC2 and choose the instance. Now the status checks for my web is passed. So I select my web, go to action, choose the image and template, and select create image. Then we configure it. So the image name is my entity. And I will add some description. And I leave everything else as default, and I create image. So to confirm your AMI has created, so go to the AMIs, and it would appear here. So now we need to create a load balancer. So move to the target group, and we create target group. We choose the instance type, and we'll create the group name here. I select my VPC, and next. So I will select my web, and I create group. Continue. Now we are to load balancer, and we are create load balancer. In load balancer type, we are choosing application load balancer here, and click create. And now I will enter the load balancer name. I will leave as default. And now I will select my VPC. In here, I will select to availability zone. And I'll select as public. For the security group, I will remove the default and I choose web S3 here. In the listening and routing, I select the target group. And now I leave everything as default and I create load balancer. Okay, so now the load balancer will show the state of provisioning. So there's no need to wait. So we are continuing to the next step. So the next step is create a LAN template and an auto-scaling group. So let's go to the LAN template. So select create launch template. And now I would label the input here. Okay, so make sure that you take provide guidance to help me set up the template. In the application and OS image to my AMI. In the instance type, select the T2 micro because it's a free tier. And now in the key pair, I'll select the book key. Now in the network setting, I will select the now in network setting in the firewall, let's select security group. I will select the web S3. And in the success dialog, select the template. So in the action here, we select create auto-scaling group. So now I would add the auto-scaling group name. In the launch template, make sure that you select the right template. And now we choose next. Let's change the VPC to my VPC. And in availability zone and subnet here, I will select the private one. So it will be private subnet 1 and private subnet 2. And I will choose the balance best for here and next. So in step 3, I will select the attach to existing load balancer. And I will select my group here. Move to the next step is configure group size. So I would increase the design capacities to the main design capacity and scaling is 2, and the max design capacity is 4. Okay, so under the automatic scaling, choose the target tracking zone policy. And I would change the name. And I would choose the average CPU utilization. And target value is 50. So this tower is going to maintain an average CPU utilization and across all the instance, 60%. So auto scaling will automatically add or remove capacity as required to keep the metric at or close to specify target value. So it would adjust to fluctuation in the metric due to fluctuating load patterns. In the additional setting, we should select enable group metric collection within CloudWatch and set everything as default. Add notification as optional, so I would next at the name tag, I would name the key's name and the value is the instance. I will select next. And I review the details of our auto-scaling group. And I will create auto-scaling group. Okay, so now we will verify that load balancing is working. So first go to instance. Let's reload it. So now you will see two new instances here, launched by Autoscaling Group. Now let me add the name for it. So it would be and we reload it to make sure that status checks of the new two instance has passed. And now in the left panel, choose the target group and select my group here. Make sure that the new two instance has been listed in the target group. Okay, so it will be here. And make sure that the health status and is checked healthy. And now choose the load balancer and select my load balancer. So here I will copy the DNS name and I will put it into the new tab. So it would appear the cafe website. So the application would appear in the browser. So it indicates that the load balancer received the request and sent it to the EC2 instance, then it's passed back the result here. Let's test the auto scaling. So I will select my instance here. And in the instance state, I will stop the instance. Now, if I stop an instance, auto scaling will create a new instance for me. So I keep reloading. So now it will create a new instance here. And it initializing. So this shows that my auto scaling works. Here are 5 resources in Task E, auto-scaling and load balancer. So in Task E, I watched some videos about elastic load balancing, Amazon CloudWatch, and Amazon EC2 auto-scaling in Module 10 and AWS Academy. Also, I did follow the instructions in Lab 6, Scale and Load Balance Your Architecture in Module 10, AWS Academy. And again, I use Sandbox for practicing. We are on tab F, deploying a dynamic website. So first of all, I will launch a new instance, move to EC2, and then launch instance. I will name it dynamic website. In the app, select the Amazon Linux 2. The instance types would be T2 micro, and the key pair is the bulk key. In the network setting, edit, and I select my VPC. Make sure that it chooses the right public subnet. And I enable the auto assign IP. In the security group, I select existing security group, which is the WebHG. In the expand detail, expand it. In the IAM instant profile, choose the lab instant profiles. For the user data, in the user data, I will paste the given user data that you have been given in the instruction. And now make sure the metadata version, it will be v1 and v2 token. And now launch instance. The next step is we are creating a security group for database. So go to security group, click create security, and I would name it as database security group. And I select my VPC. In the environment rule, I add rule. The type of the environment rule here is MySQL. And in the label next to the source, I'll select the web S3. And I'll create security group. Now we will create database subnet group. So in the search bar, type RDS and click Aura and RDS. Now we choose the subnet group. And here, create DB subnet group. And I would name it database subnet group. I choose my VPC. In the add subnet, choose the right availability zone. And for me, it's A and B. In the subnet, make sure that you choose the private one. And it will be private subnet 1 and private subnet 2. And click create. And now we are create a database. So here we click create database. I choose the option, choose MySQL. The template, I prefer using free tiers. The database instance identifier, I would name it as database and my SAD. Master username is admin. And I will manage my password. So the password will be 17122005. And confirm the password. The instant configuration, I choose the DB4 micro, and in the storage type, I choose the general purpose SSD, and allocated storage is 20. In the connectivity, I will select the connect to easy to compute resource, and I choose the dynamic website instance. Now in the database subnet group, I choose the existing database subnet group. For the VPC security group, I'll select the database security group. And now in the additional configuration, let's expand it. And keep in mind that you give the initial database name, and I would name it as database MySAD. Now let's keep everything else as default, and I create database. Once the database is created, let's select the database. In here, make sure that you copy the endpoint because we use it later. Now, in the connected compute resources, we click on the resource identifier. And now we select the dynamic website. Now in the public IPv4 address, copy the public IPv4 and paste it into new tab. Now create in the static. Copy the endpoint and paste it into the endpoint. In the database name, go to the configuration and copy the database name. And you add the username and the password and save. Here is our database, and now we can interact with the database. So we can add inventory. In the store, I would add apple. The item is apple, and the quantities is 100, and I submit it. Now we would add into the database. So I would edit. So I would edit inventory. So now it will be apples, and the quantities is 200, and I submit it. And now it has been changed. The data is updated. And what if I delete inventory? So the entries has been removed. So this is how I deploy a dynamic website. Here are 4 references I use in Task F, build a dynamic website. In Task F, I watched some videos about Amazon RDS and console demonstrations about RDS in Modern 8 database in AWS Academy. Also, I follow the instructions in Lab 5, build a database server in AWS Academy. And finally, I practicing database with sandbox environment. This is a system architecture diagram in task G, illustrate the complete AWS infrastructures deployed within a custom VPC spanning two availability zone A and availability zone B. Each availability zone contains both public and private subnets with Unix/22 CIDR blocks supporting up to 251 IP address per subnet. The public subnet hosts EC2 instance for static and dynamic website, an elastic beanstalk environment, and load balancer integrate with an auto-scaling group to ensure high availability. The private subnet are used for backend service include MySQL RDS instance, secured by security group. The internet gateway enables external access for public-facing resources, while private subnet remain isolated. An S3 bucket is also integrated to host the static version of the website. The root table, the root table are correctly associated with their respective subnet, ensuring appropriate internet routing for public and internal communication for private resources. So this setup demonstrates a robust, scalable, and secure architecture that meet modern web application deployment standards. Here are 3 resources I used in Task G. So I use Lab 2, Lab 5, and Lab 6 for visualize the architecture's diagrams and learn and understand how to draw the system architecture. This reached the end of my assignment, so thank you for listening.